Saxon's Trig, lesson 82, is about taking the logarithm of and exponential equations. It begins on page 495. So section A, taking the logarithm of, is just a reminder that if you have an exponent that is a fraction, the numerator is actually the exponent, so 100 to the first power is still 100, and the denominator number is the root number. Now that should not be new, so basically you're asking yourself, what is the square root of 100? And of course that would be 10. If you are given a statement that is log of something, it is implying a base of 10. So you're going to do 10 to what power equals the 8. And if you have natural log, your implied base is an e, which none of that, like I said, is new information. So then in part B, they say, all right, let's deal with equations that have exponents in them. So it shouldn't feel brand new. It should just be an extension of what you already know. Now there is one tiny little thing that's different. So in example 1, oh, that is a lousy looking 10. Okay, so it is 10 with an exponent negative 2x plus 2 equals 8. Now the first thing that we have trained ourselves to do is to look for, do we have the same base? Oh, no, I don't. So here is the one new thing when you're dealing with these equations that don't share the same number. Is there any way to change 10 and 8 into the same base? Nope, this one could go to 2 cubed, but 2 to a certain power does not get you to 10. So what you do is you choose to either log or natural log. So you're going to force it to either go to a base of e or go to a base of 10. Doesn't really matter which one. Your answer should still come out very, very close. So because this one is a 10, I'm going to choose to log both sides. So when I do the log base 10 of 10, they cancel off and I just keep the negative 2x plus 2. And then when I do log of 8, I get it to a decimal on the calculator, which would be 0.9031. And then everything else is merely solve. So that is minus the 2 and divide by negative 2, and you should get x equals 0.5485 if you work that out on the calculator. So example 2, I've gone ahead and written it out, and because it has a base of e, you're going to natural log both sides because that will be a beautiful cancellation and just keep the negative 2x plus 3 equals, and then the natural log of 5 should come out 1.6094, and then your algebra minus the 3 divide by the negative 2. So x should end up being 0.6953 or something fairly close to that. And if you want to practice example 1 doing it with a natural log or example 2 doing it with a log and see how close you get, that's totally fine. Now in example 3, the bases do not give me any sort of a clue. Honestly, it is your call whether you want to log or natural log. And just so I can match the numbers in the book, they chose to log. And so you're going to get a decimal for log 5, and that should be 0.6990. And that's going to multiply with the exponent dropping down, 2x minus 1 equals, and then the log of 6 should give you, just a second, I feel like I've jumped examples. I did. Okay, I'm looking for the decimal for log 6. There it is, 0.7782 multiplying with the exponent of x minus 2 dropping down. And just because I had trouble with that, let me make sure I didn't pull a decimal from the wrong place. No, I'm good. Okay. Then distribute out the decimal times 2, so something or other x, 1.398x minus 0.6990 from where I multiplied with 1, equals 0.7782x, there was no change, and then negative 2 times that should give me 1.5564. put like terms together. So this one is smaller. Let's minus this one from this side, making 0.6198x equals, adding the 0.6990 with the 0.7782, negative 0.8574, and then dividing by the 0.6198, so x equals negative 1.3833, or something within that ballpark. You do not have to carry it to 4 decimal places. Last example says to solve 4 equals 6e to the 2x plus 3. Now, because this one has an e in it, I am going to natural log both sides. And when I do that, remember that a 6 multiplying with a natural log makes it multiply with the other part of the exponent. So natural log of 4 is going to be 1.3863 equals, and then that decimal from the natural log with the e is going to cancel off. So then you basically have your, oh, wait a second. No. Even though the 6 is multiplying with the natural log, you want to natural log each piece. So it's its own individual piece. You're going to natural log the 6, then natural log the e. Sorry for the confusion on that, which will cancel the e part and just keep the 2x plus 3 here at the end. And when you're multiplying, it's really adding. So natural log of 6 gives me a decimal 1.7918. And now we solve algebraically. So there's only one x here, so we can add this with 3 and make it 4.7918. Minus when I bring it away from the x term, so 1 point something minus the 4 point something should be negative 3.4055 equals 2x, divide by 2, and that should be negative 1.7028.